Hello and welcome to Domain Name System DNS class. Okay, so today we're going to have some learning objectives. We're going to say why do you need it. We'll have some exercises, a learning verification, and a summary. Here are the learning objectives. What is a forward query? What is a reverse query? What is recursion? Are reverse lookup pointer PTR records required? What is iteration? Why do you need it? Okay, well, because maintaining a single host file for the entire internet, yes, it was like this in the beginning, did not scale as the internet increased in size. Also, who wants to type in this? https://192.168.230.240. Also, what happens when the website changes IP address? Also, I mean, would you really, you may say, oh, I can handle this. Okay, how about IPv6? Would you really want to type those in manually? Come on, people. Now, exercises 1 of 8, DNS forward query. What is a forward lookup? A forward lookup is for a case when the resource name is known, but the IP address is not. In this case, I'm using the nslookup command in Windows. The type is A, looking for a host record for this resource name. It's querying my DNS server, which is specified here, and it's actually providing this result here. And it's saying for this name, use this. This is the IP address of that host. And that would be a forward lookup. Now, DNS reverse query. What is a reverse lookup? Well, you know what forward is. So a reverse lookup is used when the IP address is known, but the resource name is unknown. In this example, I'm using nslookup. The type is PTR pointer for the reverse entry for 4.2.2.2. And then it provides this answer, which is for this 2.2.2.4.n-addr.arpa, the name is b.resolvers.level3.net. Notice for the pointer record, the IP address actually is in reversed notation here. Did you notice that? Okay, now, what is recursion? Okay, recursion is when DNS asks others for the information. The internet is too big for a single DNS server to hold all the DNS records. Remember, they found this out back in the beginning. For this reason, a server will ask another server for the DNS records. Now, there is a related term, iteration. Iteration is when the DNS server checks where the record might be, then tells the requester so that the requester can check for itself. Okay, what is non-authoritative? Because as you'll note in this nslookup command output, it says the answer is non-authoritative. Non-authoritative. So, non-authoritative means that the answer came from a cache or that this response was forwarded. It basically means that you did not get the results directly from the source. Remember, DNS is too big for one server to know it all. Remember, similar to ARP and MAC address tables, there is some state information that is cached so that future lookups can be faster. I mean, if all lookups had to iterate back to the authoritative name servers, DNS would be a bit slower than it is now. Okay, now DNS record types. Now, what are these DNS record types? We see A, we see AAA, we see PTR, we see MX, we see SOA, we see NS. What are these different DNS record types? Well, a type A is for an IPv4 address. It will actually resolve a name to an IPv4 address. Type AAA is for IPv6, and it will resolve a name to its IPv6 address. Pointer, the PTR, will resolve an IP address to a name. MX, mail exchange. This is for email routing, so the MX records will refer to the mail servers. SOA, start of authority. This contains core information about a DNS zone. Some of you may find something like a time to lives, and sometimes there'll be a contact information for that DNS zone. NS is a name server. So NS, if you do an NS query, for the NS type of records will be the list of authoritative name servers for a particular domain. Okay, name not found. What happens when you go to www.example.com? Note, it is www intentionally in this case for purposes of this example. In this case, you'll get a result similar to this. This site can't be reached, and the browser actually gives a helpful error message. It actually tells us error name not resolved. It lets you know right here that there was actually a DNS problem. And because we know this isn't a valid name, but this was useful for this example. Now, we can do an nslookup test. Now, what happens when you nslookup www.example.com? And what about when you nslookup www.example.com? Okay, we tried it here, and as we see, the Cloudflare DNS that we use as our DNS server tried to help us out, but it just could not find www.example.com, and the response to that is non-existent. Now, when we ask for www.example.com, it says, okay, I can find results for that. Here you go. Here's my non-authoritative answer for www.example.com. Exercise number 8, nslookup scenarios. What happens when you nslookup these and why? In one case, we're going to nslookup http://www.example.com. In another case, we're going to nslookup www.example.com. Answers on next slide. Now, please note the test using HTTP fails because http:// is not in the name. HTTP here actually refers to a protocol that's being utilized to reach this resource. The resource here is www.example.com being reached via the HTTP protocol. That's what that actually means. So that's actually not the name of the resource. And as we stated before, DNS was about, resource names. And this is the name of the resource. And for that reason, it could find this resource here, www.example.com. This example is included because sometimes, this is a mistake that can be made, that people attempt to look up the URL and not the resource name. Now, learning verification. What is a forward query? What is a reverse query? What is recursion? Are reverse lookup pointer PTR records required? What is iteration? Okay, so a forward query is when you know the name but not the IP address. A reverse query is for when you know the IP address but not the name. Reverse records are an optional part of DNS. Do not count on them to be there. Recursion is utilized to find resources that cannot be located within the cache or by the local DNS servers. In this case, the servers are asking someone else. Now, iteration is when the DNS server tells the host to ask a different DNS server. In recursion, the DNS server does the work. In iteration, the DNS server tells who's ever asking it, hey, you can go over here to find out. Now, you can nslookup resources, but you cannot nslookup including the particular protocol or application that's going to be utilized. For example, you wouldn't nslookup including HTTP or HTTPS or FTP or Telnet here. You would not nslookup that. So, for example, nslookup www.example.com is good. nslookup http://www.example.com is bad. HTTP refers to Hypertext Transport Protocol and is not part of the resource name. It's a protocol used to reach the resource. Hopefully that's clear. Now, please note, DNS can break a lot of stuff. You can't get on the internet, it could be DNS. Because as we saw earlier, with the case of the www.example.com, it was not valid. DNS could not find the name and we could not get to that site. Now, email not working. As we saw, DNS, there are mail exchange records that are necessary if you're trying to use email. And if those MX records, if there's issues with those MX records, you could call email issues. So if your email is not working and maybe you recently changed providers, you may want to check your DNS records. If you can't join a computer to the domain, believe it or not, DNS is involved in this also. Usually, the primary DNS on a system, when you're first trying to join a domain, better be able to locate those domain controllers. If not, you may not be able to join that computer to the domain. The internet is slow. Well, that could also be DNS. If your DNS server was slow, then, because everything you usually look up on the internet, you're not typing in a bunch of IP addresses usually. You're actually using some sort of DNS that resolves many names for many resources to IP addresses seamlessly for you in the background. But if these DNS records take a long time to return, it can make your internet slow. And of course we don't like slow internet, do we? Of course not. Now, keep in mind the answer is not always DNS, but it is always worth checking DNS. So for example, someone has issues with internet, hey, check and make sure the DNS is healthy, that you can resolve that name. You know, the email's not working, hey, check the MX records. Can't join the computer to the domain, hey, check the IP configuration of the host. You know, internet slow, hey, is DNS returning quick results or is there something hanging up here? So hopefully you guys had fun and really enjoyed this class on the domain name system DNS. Thank you very much.